G'day, welcome to the channel. My name's James, hope you're doing well. Now today I've got for you a story about a reflow oven. But before we get started, I would like to first thank everyone for the support they've been giving me on YouTube with their comments and following along with the channel. Now we've reached a small milestone. We've just got over 1,000 subscribers, which is pretty cool and exciting. And to celebrate, I'm just giving away one Reflow Master. Now the Reflow Master is a project that was created by Sion from Accidental Maker, another YouTuber. If you want to check out his channel, it's down in the description down below. Now I think it's a pretty cool little project, and we're actually going to have a look at that project today. We're going to try it out and see how it works. If you would like to get one, then please check down in the descriptions to see how you can win one of those if you would be able to use it and make use of it. Complete and tested.
Daddy, can we just get started?
Can we just get started? Yeah, okay, let's just get started. Now, a few weeks ago, I received in the mail my Reflow Master that I purchased, and it was Friday afternoon, and I just wanted to try it out. I wanted to stick it in my Reflow oven and give it a go, and make a quick video about it. G'day, welcome to the channel, it's James here. Today, I've got a quick project to share with you. It's actually not my project, it's from another YouTuber's channel, Sion from Melbourne, and he has made a device called a Reflow Master. And it's time, I've decided it's time to make the Reflow Master, or fit it I've bought it from his store, and I'm going to fit it to my toaster oven. Up until now, I've just been sticking my PCB boards in the oven and turning it on and turning it off, and it sort of worked, but it's a bit messy. The flux doesn't have time to act, and the boards aren't that great, and I'm using smaller components with finer pitches, and I'm finding it quite difficult to get a good result. So I thought it's time to do that now. I don't have all the parts I need. I don't have an SSR relay or a... So Friday afternoon, I continued on with my video, and I made the Reflow Master with a mechanical relay, but it was pretty clear that for it to work properly, it needed to have a solid state relay. So I went off and got myself a solid state relay, and I continued on with the project the next day. So I'll show you what I've done so far, and this is my temporary hookup. Basically, I've got my temperature probe, which came with the kit, and I've just got that in there, the K-type temperature probe. I've just drilled a hole through the outside, and it comes up here to the Reflow Master controller. Now, I didn't order the box, so I printed that on my 3D printer, and it was pretty easy to print. It didn't take too long. And the files are available on Sion's website, on the GitHub site. It's got a switch here just to turn it on and off. Now this device runs on a USB power supply, and the brains behind it is a little SAMD21G microcontroller, which you can plug into the Arduino interface, and it acts you can reprogram it however you like. I'll open it up. So inside here, you'll see the power switch, and we've got a few little terminals on here. So you can actually connect up a fan for cooling down, which I haven't actually got to do today, but I might do that later. And we've got the K-type thermocouple that connects on just here. And we've got another two connectors here to connect the solid state relay to, and that's just a 5-volt output to turn on the relay. And we've got the main circuit board just here, with the SAMD just on the other side of there. We've got the USB connector, and which you can use to connect it up to an Arduino IDE, and you can alter the code on it if you feel so inclined. And it's got the touch screen, not a touch screen, it's got a color TFT screen that's there that plugs into it, and a little beeper to tell you when to open the door when it's finished. So that's it. It's a pretty cool little device, and I've got this connected up so that the relay, when it operates, is controlled by this. It just simply turns on all the elements inside this oven. So I've got some elements down the bottom, and I've got some elements up the top. I think it's a 1700 watt oven, and it's got a fan just here which I've left connected as well, so to circulate the air around. And it's pretty simple to do. You just rip all the connections off this, so this doesn't do anything anymore, and we're just going to wire it up inside. But we'll open it up and we'll do it properly. We've got a solid state relay with zero crossing that we can install inside to turn it all on and off. And we'll hook it up properly and perhaps put a bit of insulation in here to keep the heat so it works a bit better. All right, let's get started on it. So it worked better with the SSR relay, the solid state relay, but it didn't have the power to do anything other than a low temperature profile. Now the Reflow Master has a test program that you can run, and it checks to see if your oven is capable of doing the temperature in the time required to reach the profiles. And my oven could only just reach a low temperature profile. And it simply was too large in size and didn't have enough power to heat up quickly enough. So I thought I would improve it by adding an element into the bottom of it. The only thing was that made it pretty much really dangerous because all the terminals were sticking out the bottom and it didn't really work. So then things went from bad to worse in that I created Frankenstein's Reflow oven. I think it's best you just check it out. And today we're making Frankenstein's Reflow oven. I received my Reflow Master in the mail a couple of days ago and I thought I'm gonna stick it together right now, which is what I did. I installed it into this oven here and quickly discovered that it does not work with an ordinary relay. It definitely needs a solid state relay. So I went off to get a solid state relay and tried the official temp #1 in the oven. It worked really well. It was pretty awesome, and I thought that I should make a better video, one that justifies how well it works. And so I started making another video, but this time I had the addition of an element in the bottom, hoping to get a higher temperature profile working in the oven. You gonna show them, Leo? No? No, sorry, you can't see it. You are, okay. Where is the element? Is that it there?
Yeah.
So we put an element in the bottom here. The only problem is that this element is too slow. It's really slow to heat up and it keeps its heat because it's so heavy. So in an attempt to make a reflow oven out of toaster ovens, I've gone and purchased a smaller oven. This one just here, from Kmart for 30 bucks. And the idea, I was going to put the elements out of here into here to boost the heat on it in a smaller space. However, just looking at what we've got here, I am thinking that we could actually do this. I don't know if it's going to work. Can we fit that in? Can we fit that in there? Yeah? Yeah, I think we can. We're going to try and fit this in here.
Daddy, it's gonna pop.
It's going to pop. Oh man. Now, Frankenstein's Reflow oven actually worked really well. On low temperature and medium temperature profiles, it was really good. The only problem was it looked ridiculous and was pretty much impossible to replicate. And there's also the potential of fire from the insulation that's not really designed to be in the oven catching on fire. Anyway, we decided that it would be best to test it out with an egg as an experiment. It's not, is it? Look at the top. Top's going.
Oh, it's going now. It's still not getting hot enough.
Yeah, it's not. We need more power. We need more power.
Infinite power.
Wow, check it out. It's awesome. I wonder what's going to happen to the egg.
Well, I want it to explode.
I don't know if it will.
I think we all do that. That's kind of the whole point of me bringing up the whole thing. I want to see an egg blow up.
Well, I'm glad it worked. So this is a medium temperature paste. It's not even a high temperature paste. But you'll see it does pretty good at keeping the temperature once it gets up there. It's actually not too bad. That would still work all right. To reflow a board. It's just the peak, it's whether it gets to that peak up there. And I might need to calibrate it a teensy bit because it's a little bit over, maybe, I think. I don't know if that's how it will work. I think it's going to work, eh?
Like you think it's going to work as a reflow oven, or it's going to work?
No, it's going to get to the top temperature thing. Because before I did it and it sort of didn't make it. It makes me want to try the high temperature run. Oh, it's working. Look at that. It's beautiful.
But there was no explosion.
There was no explosion. Oh no. We can now confirm that it's only microwaves that blow up eggs.
Well, we can't confirm that yet, but we can pick the egg up and go and put it in a microwave. Or you can just let me go and throw it on the ground outside on like the road. Is that vandalism? Is that illegal?
Yeah, it's vandalism. Well, I'm happy about that. That worked. That's a successful experiment. Frankenstein's oven has worked for us.
It's alive!
But the truth is, I found that it's a wire I forgot to connect the neutral.
Well, that's embarrassing. Well, considering it was such a small problem, let's just not even put it in the video.
No, we have to include the truth. Maybe we should not include it, I don't know. I'll decide later. And the truth is, up until now, we don't have a practical reflow oven yet, but it's about to change with version 4. So here is the actual practical reflow oven that you could possibly make as well if you wanted one. Okay, so I believe this is the 4th attempt at the reflow oven, and hopefully this one's going to be a little bit less Frankenstein than the last one. Now, I got this from Kmart for 30 bucks, so that's one of the first things that's good about this particular oven. And we're going to open it up and have a look inside, and we'll see what else makes it a good oven for a reflow. Okay, so this is the oven unpacked, and if you have a look here, it does have a gap along the top here. But we're actually going to make use of that because we're going to install a fan to cool it down at the end of the cycle. So the air will get sucked in through here, and the plan is to suck it out the back here and up through an exhaust fan. Now, in addition to that, it's small, it's only 9 litres, so there's not much space to heat up. And it has the quartz infrared elements, and these seem to do a better job of heating than the other type of element that you can get, the convection elements. So that's the reason why. So if you look out for these elements, just there, that type, they sort of look like a glass tube with the heating element inside it. They tend to do a better and faster job of heating. Okay, so I've opened it up and you can see that it's got two 120 volt elements inside that are run in series. Now, the thing is we want to get the bottom one out and remove it and cover the holes. And you can see over here, there's not really much going on inside this oven, so we can disconnect all of this. And then what we're going to do is we're going to cut a slot here, and I've made this little plate up where we can mount 4 of these elements across the top of the oven to do the reflowing heating. And I've got 2 out of another one of these ovens, so I got another one of these ovens. But I'm going to try it with just the 2 running, and then I'm going to try it with the 4 and see if you need to have 4 or not. Okay, so I've progressed a little bit along now, and I've cut out a slot here. So this little plate will mount in here like so, and the elements will mount in that plate. And I filled up these holes here. And I've also installed my little vent at the back. So that's just to shut off the air when it's running, and then when the fan comes on, hopefully that'll pull up the vent and it will suck the air through to cool down the reflow oven. Hopefully that works. All right, we've just got to cut out this other side, and then we can mount the elements. Okay, so I've got this plate mounted here, and I've got my elements sitting in here. So they run through just up the top there. So what I did was I just fed the elements into that plate, and I'll put this plate on, and then I'm going to pop rivet that in place once it's all in position. Okay, so we've got the oven all connected and ready to try out and give it a test run. We've got our elements are looped at this end, so there's 2 circuits and 4 elements. So that gives us a total of 2,000 watts. So it's pretty powerful. And inside here we've got some boards set up just to try out. I haven't actually got solder on it, I'll do that later, but just to check the temperature profile. The thermometer, we're going to have to reposition that later and bring it in through the roof. I've just put it there for now just to give it a test run. The connections are done on this side. So we've got the 2 elements and the neutral just coming in here, and the power coming in here. And that is getting controlled by this solid state relay, which has been controlled by the Reflow master. And I've also connected up a little relay board here to turn on our exhaust fan for cooling it down. Now I was going to swap that out later for a smaller fan. That's a 150 mil this fan, but I've just got this aluminium core duct for venting the hot air out of the reflow oven. And I've just put a little spigot on the back here, and there's a little door at the back there. You can see it. So that sort of keeps the hot air in, but when the fan starts, it opens up and lets the air get drawn out. And it's pretty good because this door is quite gappy and the air does flow quite well with the door shut. And if you want it to cool fast, you can open the door, of course. So I've given it a go already, and it's amazing. I don't think we even need insulation for it to work properly. And I'm fairly confident that it will be pretty good even with 2 elements. So you don't need to get 2 of these ovens, you can just get 1 and transfer one of the elements to the roof like this. Anyway, let's try it out. Okay, I've done some more tweaking, and I had trouble with the fan, and I found a new firmware for this Reflow master and installed it, 1.07, and it said fixes to the fan. So I've been trying it out now and it's going pretty good. I've adjusted the settings a bit and it's keeping to the profile pretty sweet. Except for just then when the thermostat came unstuck and hit the elements. It was going pretty good. That's right, it's back to normal now. The fan's just started now, and the door is actually still closed. But you can see that it's making a pretty big difference. It sucks air in through the door, around the edges. And I've found that it's actually better to not open this oven. For some reason, if you open it, the temperature actually goes up. I'm not sure if it's just the sensor or... I'll open it. Oh no, it's alright. Okay. Well, that's pretty good, except for where the temperature probe came unstuck. Nice. Well, that's it. That's a pretty sweet profile from a $29 Kmart toaster oven, and of course, most importantly, the Reflow master and solid state relay and an exhaust fan. I'd like to thank you for watching the video. I hope you found it interesting. And once more, if you want to see other projects that Sion works on, make sure you check out his channel. He's got some pretty cool stuff going on with the tiny Pico, and he's got a pick and place machine that he's working on that's driving him crazy, I believe. Lots of interesting stuff happening over there. And once more, thanks for the support you've been giving me on the channel. And if you want to see more videos on home automation and electrical installations, then please subscribe. I'll see you next time.